Welcome to Code Club. You join me with another panel of excellent gophers from the internet. Erin is here. Hello.
Hello.
Anusha is also here. Welcome to you.
Hello.
Thanks for joining. Jakub is here too.
Hello.
Code Club regular. Thanks for coming back. So we've looked at a variety of different Go programs on Code Club, haven't we? From quite small ones to quite big ones. I think this is probably going to be one of the bigger ones. I'm not sure, I haven't looked through all of it, but the project that we're looking at today is the GitHub CLI itself. So this is a Go-based tool for accessing GitHub from the command line. It's the GH command. So, Anusha, you're driving. Thanks for volunteering to do that. So, why don't you decide where we should start? Do you have an idea where would be a good place to start, or should we just drop in somewhere randomly?
The entry point?
Yeah, how do you approach this sort of thing? And when you read Go programs for recreation or amusement or learning, if you do, how do you tend to read them? Do you start with main, and work your way through, or do you look at tests first, or is there a particular pattern that you have?
If there's a main file, then from the main file, main.go file. If not, if there's a CMD folder, then from the CMD folder.
Yeah, I do the same. So let's do that, shall we? There is a CLI with this. We know that's what it's all about. So let's see if we can find it, because we have... It's a big repo, isn't it? There's a lot of stuff here.
Yeah.
Let's see what we can find. Can we find a main.go? Yep, that looks like the one, doesn't it? So, for those who are new to Code Club, the idea of this is basically to sort of practice our code reading skills, and I find it's a really great way to learn more about Go, and I certainly did this when I was learning. It's just to read other people's programs. They're not guaranteed to be terrific programs. A lot of them aren't, but it's instructive either way, isn't it? Sometimes you look at them and think, well, I don't really understand that, in which case, maybe it's just not great code, or maybe it's just something I don't understand. It's useful either way. So what I tend to do is just, I'll pick some part of the program and I'll just start reading, but in quite an intentional sort of way. Oftentimes we're just skimming through, aren't we, looking for the bit that we're interested in. And I find it's great to just stop and slow your brain down a little bit and just say, what does this code actually say? And that's sort of, for those learning Go or completely new to Go, that won't necessarily be easy. We can make some guesses about exactly what the syntax means, or, what's happening in a particular piece of code. And then there's kind of a higher level thing, isn't there? Once we know what the code says, we can sort of ask ourselves, well, what is it doing? Why does it say that? What's this actually about? So, shall we try? Erin, would you maybe start us off by just trying to read some of this? And you can start with func main if you like, or we can look at what comes before that, whatever you prefer.
Okay. I am new, so I will definitely not know a lot of the things that are here.
Yeah, that's totally fine. In fact, that's excellent, because a lot of the people watching will also be very new to Go. So, say what you see, but the minute you see something you don't understand, just say, I don't understand this, what does it do? And we'll try and figure it out together.
Okay. I guess we can start above the main function. So there's a variable, it's a string called updater enabled, and it's empty. They're setting it as empty. And then you're creating a type that's an int called exit code.
Yeah, that's a perfect reading. All correct so far.
And there's some constant variables for the exit code, I'm assuming. So if exit is okay, it returns, it's a 0. If it's an error, it's a 1. Creating that
Yeah, that's
connection.
perfect. So can we guess what this is about? This is open to the panel as a whole. What do we think's going on here? We've got updater enabled, we've got an exit code type, and we've got some constants of that type, as Erin rightly said. We haven't seen these used yet, have we?
No.
Maybe it'll become clear, later on, but if we were to try and guess right now, is there anything we could think of?
I would say some predefined the codes for the errors possibly returned.
Yeah, well, we're in main, aren't we? So
Yeah,
exit code suggests this might be the status that we're exiting the program with.
Yeah.
So again, not everybody may know this, but generally, when you run some program on the command line and it exits, there is some number associated with that, an exit status or exit code, whether it succeeded or failed, isn't it? Like 0 usually means success, everything's fine. And some non-zero exit status means something went wrong, There's no predefined semantics about exactly what, but we could have guessed that that would be used for exit status. Fine. So, Erin, you're doing a great job. Please continue.
Okay, then we go into the main function.
Yep.
And create a variable called code that is set to the return of main run.
Yep.
And then is used, I'm assuming that one of those exit codes comes back, because then there's an exit that's getting the code.
Yeah.
I guess I don't really know for sure.
Yeah, that's fine. We're often working a bit in the dark, aren't we, when trying to read programs, and that's okay. I think part of the skill is just being comfortable with limited information, isn't it? I know some people who have real difficulty reading code because they need to understand everything at every point, and often it just isn't clear until later on what some variable is for or whatever. So, it can be sort of useful to just say, if it's immediately obvious to me what this is about, great, but if not, I'll just kind of keep it on my mental stack, and I'll think maybe there'll be something that uses that later, and I'll figure out what it's about. And maybe not. This is why it can be helpful to run through something again and say, it's like reading a novel, when you find out who the murderer was at the end, then when you read it again, you read it with very different eyes, don't you? So this is fine. So we know there's something special about func main, don't we?
You mean that entry to the program?
Yeah.
This is actually the first that we execute.
That's right. There is, so a lot of Go programs are command line executables, but not all of them. Some of them are just libraries, aren't they? So if you had some package, there are some packages in this repo. But there's a special package called package main, which is the one that you need if you're building some binary. And there's a further special magic function within that called func main, which is the one that will be called when your program runs. Again, this is stuff which, if you're not familiar with this sort of paradigm, you might not know. It's similar in most languages, isn't there? There's some predefined entry point like this. This is the one in Go, main.main is what it is. And we can see that this main doesn't actually do a whole lot. Like, it's just 2 lines. And that's actually great, because it means we're really calling some other function to do all the work. And as Erin pointed out, there's some function main run, which returns something that we call code, and then we call os.Exit to exit the program with that status, whatever it is. So it sounds like main run is the thing that does the real stuff, and then it'll just return some code, meaning everything's okay or things went tragically wrong. Either way. So let's find out what happens. Please continue.
Okay, so then there's the main run function that returns one of those exit codes.
Yep.
Of the exit code type. And then there's a build date variable that's created, and a build version. That's build.date, build.version. I don't know exactly what that is.
No, nor do I. Maybe we'll find out. But we can guess what those are about, can't we?
Yeah.
We just don't know where
Yeah,
they
the
come
names
from.
probably are a clue.
Yeah, it's quite possible this could be injected from somewhere. So when you build a Go program, you can supply values for variables on the command line. This is a lesser known trick, but quite useful. So if you have some variable in main called version or whatever, you can supply a flag on the command line saying set main.version to X. You know, could be part of your make file or something. So maybe they do that, maybe they do something different. Let's see. What's next?
And then there's an update message chan variable. And honestly, I don't really know what make with things behind it means.
Fine, let's see if we can figure this out. So there's some function called make. This is a built-in function, and it takes something chan pointer to update.releaseinfo. So what do we think this is about? Anybody have any ideas?
So we are creating the channel and we will be sending the data, which is the basically pointers to release information.
Right, what does make do, just to refresh our memories?
Create the new object of the given type.
Yeah, exactly. It makes things, doesn't it?
Yeah.
So if you have some type, you can say make me a variable or make me a value of that type. You wouldn't need to use it for things like strings or integers, because you could just use literals of those, couldn't you? You could just give the string itself, no need to call make. Anyone know why make is useful then? Why would you call make for things?
That was going to be my question.
It's an excellent question. Let's see if we can answer it.
Is it when we use main, I believe we create some object with 0 values, right? I'm not sure about the channel in this case, to be honest.
Yeah, if we think of some examples where we would use make, one is with slices, for example. So if we
or maps, for example,
yeah, suppose you declared some variable of type slice of int, let's say. The value, if you just declared it with var, var x slice of int, the value of x would just be nil, wouldn't it? So it's not even a slice. It's just nothing at all. You can't index it. You can't look at it. You can't do anything with it. You certainly can't assign to it. That would panic. Same with the map. So you need to do something to turn a variable of a slice type into an actual working slice that you can do things with. That's what make does. Is it actually makes the slice, and it's really about memory, isn't it? There is some chunk of memory that's being allocated for this, and make does that, and will give you back the value. And we don't always need to call make, because an alternative to that might just be to, again, assign it some literal, isn't it? We could imagine just assigning an empty slice literal to x, just empty curly braces, and that would work too. So we don't always need make. There's one time we absolutely do need make, and we can't manage without it, which is with channels. So, and that's what we're dealing with here, isn't it? So there is a thing in Go called a channel, and it's unique to Go, but not, the idea of channels is not unique to Go, but this is how Go does it. So channels are about communicating between different Go routines. So what is a Go routine? Well, we're in one right now. There always is one. It's some executing thread of your program, if you like, not necessarily a thread in the traditional sense. But the cool thing about Go is you can create more than one. You can have some other Go routine which is running in principle at the same time, isn't it? If you have multiple CPUs, which you probably do, then you can run at least one Go routine on each of them, which is nice. Some problems are concurrent, and it's nice to be able to do things concurrently. But if those Go routines need to communicate, that's a little difficult, because you could imagine maybe, let's make it concrete. Suppose you wanted to fetch the contents of a dozen different URLs, let's say, and you think, well, these network requests are going to take a while, so why don't I do them all concurrently? No point waiting for one to finish and then doing the next, and so forth. But they're supposed to produce some information, so where does it go? Are they going to write that information into some global slice? Well, that would cause a problem, because you could have different Go routines trying to access the same memory at the same time. That could get very confusing, and you could get invalid results. So the channel is a nice way to do this, and you could think of a channel as being basically like a pipe sort of thing. You stuff values into one end, you get them out the other, maybe. So this is what we're doing here, is we're making a channel of some type. So a channel has a type, which is basically the types of values that you can stuff in it. What's the type we're dealing with here? It's a pointer to update.releaseinfo. Who knows what that is, but it's some type. So we are creating one of these channels, which implies a couple of things, doesn't it? It's implying that, firstly, there's going to be some other Go routine, because if there's only one Go routine, you don't need a channel. There's no one to communicate with. And it also means we're going to be sending some data from one Go routine to another. That's always a good thing to do. And I think we'll see that right now, won't we? Because there's a Go statement here. So again, for the uninitiated, this is going to create a Go routine. Erin, do you want to try and read this?
Okay. There's a thing that says Go func, and I'm not sure what that means, but inside of it, there's a variable rel and blank. Two pieces of info, I think, that come back. That is a check for update function that returns to that variable. Looking at the build version.
Yeah.
And then update message channel. I don't really know what the arrow pointing. I've seen that before, and I really don't know what that means.
Right, let's see if we can find out.
Does it mean send it through that channel?
Yeah, exactly right.
That's what it looks like it means. Go that way.
Yeah. Well, you did great, because what I like about the way you're reading is, unlike some programmers who may be more experienced, you're reading what's actually there. Whereas the tendency is, if you feel you kind of know, you just sort of skip over it and say what you think is happening, don't you? But you can sort of accidentally skip over important stuff. So with some people, it's quite difficult to train them to sort of stop thinking and just look, say, what does the Go code actually say? Don't give me your interpretation of what you think it does. So that's excellent. So let's try and interpret this now. So Anusha, what do you think is going on here with this Go statement? Any ideas?
We are spawning a Go routine.
Yeah.
And in the Go routine, we are checking if there is an update and passing build version as an argument. So we might be checking if there's a new update after the build version.
Yeah, that sounds totally believable, doesn't it? We've got some build version, which is the version of this program. We get that from somewhere, don't know where. We pass it to some function called check for update, and it sounds like, as you said, that's going to say, is this in fact the latest one, or is there an update available? We've all seen this kind of nagging prompt. Every time you open something, it says, hey, there's a new version. Would you like to use that instead? No, I'm fine with this one. And that clearly returns two things. As Erin said, there's something that we call rel. Don't know what that is, and something else. The more experienced gophers might be able to guess what that blank represents. Any ideas, Jakub?
Yeah, so it's some returned variable. This could be probably omitted error.
Yeah,
that we are not checking. Yeah.
Almost certainly an error, isn't it?
Yeah, exactly. Yeah.
And Anusha, if you hover over the call to check for update, we should see a hover tip that tells us what that returns, shouldn't we? So, yep, you're absolutely right. That returns a pointer to an update release info. That's the same thing that the channel is meant to store. And some error. What does this underscore mean then? Any suggestions?
Let's ignore this.
Yeah, it basically just says, I'm not interested, isn't it? Like, if there would normally be some variable name there, usually error, and then we would do something with that, like check if it's not nil. But we're not doing that here, and this underscore is called the blank identifier, and it basically means I don't care, talk to the hand. I'm not interested in whatever that value is. I'm not going to use it. If you did receive it, and then you didn't do anything with it, that would actually be a compile error, wouldn't it? So you might have come across this with Go, that if you have some variable that you end up not using, it just says, I don't think you want to do that. No pointless variables allowed. And the same with imports. You're not allowed to import something and then not use it, which some people hate that. Some people love it. I think it's quite nice. Keeps my program tidy. But it can be annoying sometimes. So what we're really saying here is, check for update can return error, but for whatever reason, we're not going to look. We're just YOLO it, If there is an error, then I assume that will lead to problems down the line. But I don't know. I just find that's, sometimes you look at the program and you say, well, of course, due to the way that I'm calling this, there never can be an error. We don't know what that error could be. Maybe it's like if the build version is blank, check for update would fail. Or so that sounds like it makes a network call, doesn't it? Check for update. Obviously, network calls could fail. Well, if that happens, then what would rel be? Well, it's a pointer, so it would probably be nil. And then what we do with that is we send it to update message channel. That's what that left pointing arrow means. And somebody is then going to presumably receive that. Otherwise, there's no point doing it, is there? We don't know who that is yet. Maybe we'll find out. Probably us. It would make sense to do that here, wouldn't it? Should we carry on and see what we can figure out? But just as a footnote to that, though, we talked briefly about Go routines, and we said this Go statement creates a Go routine in some unspecified way. We don't need to know the details, but it takes some function. It actually takes a function call, isn't it? So there's a slight difference there. There is this bit with func and the empty parentheses and then curly braces. What that really means is, here is a function literal, right? We can define functions by saying func main such and such and such. That's fine, but it doesn't do anything. You have to call main. But we can also treat a function as a value. Just like any other Go value, we can pass it to functions, we can return functions from functions and so forth, and this is fun. And Go takes a call to some function, and we can see these empty parentheses on line 58. It's like we define this anonymous function literal. It's just a function that has no name, but here it is inside the curly braces, and then we call it. So that's what we're saying, is we're saying, please, runtime, create a Go routine for me, which is going to run this function. Any ideas about when this might actually happen? It's not entirely clear, is it? There's a couple of possibilities. Anusha, what would you say if you had to guess? You could say either, you know, this other goroutine starts running immediately, and this goroutine is possibly paused, or do they both start running concurrently, or does this one continue and then maybe the function runs later? What do you think?
I think it runs later.
Yeah, I think so too. So, you know, this is something where you could imagine if you just sit down and write go such and such, it sort of feels like that's going to happen right now, doesn't it? That's a reasonable assumption, but it's actually not the case. As Anusha rightly says, what we're really doing is we're saying, here is a go routine which I would like you to run when possible. You know, it may be that actually we only have one CPU, so we can only run one go routine at once. And we will just continue running this one. So the go statement will actually do nothing right now. But it has added this new go routine to a queue saying, please run this whenever you get the chance. And one time we get the chance might be when this go routine blocks for some reason. We could be doing some I/O, or we could be making a network call, or maybe receiving from a channel, you know, where there's nothing on the channel, and we would block then, and the runtime would say, aha, I have an idle CPU, I have the opportunity to run some go routines from my queue. And that's when it might start running. So the answer is, we simply don't know. We have no way of knowing when or even if this other go routine will run. We hope soon, but that's all we can say. So that's great. So thank you, Erin. Jakub, would you take over the reading duties for a minute? Give Erin a break, and let's see if we can continue figuring this out.
Yes, so from 60 line, right? Starting.
Mm-hmm. Yeah.
Okay, so we have some variable has debug defined here and assigned the value. So we are reading the environmental variables if it's debug, right? If it's defined. And I guess here that if there is no font, this debug, we are assigning has debug basically empty string, correct?
I think that's close. But this is a slightly confusing bit of syntax,
it reminds me Ruby from many years ago. I'm confused because I see first time, to be honest, in Go code this construct.
Yeah. So some of us might have seen os.GetEnv before, and if we haven't, we could maybe guess this is how we get the value of some environment variable. So there can be some environment variable debug, okay, and getEnv would tell us what it was, and we could imagine if it was just something : equals os.GetEnv debug, we'll just assign it to some variable, isn't it? But that's not quite what's happening, because there's actually more. On the right hand side of this assignment statement, we've got os.GetEnv debug not equals empty string.
Oh, yes,
right.
That's true.
What is that actually? It's actually a Boolean expression, isn't it?
Altogether, right. Yeah.
It's a logical expression of the kind of thing that you could put in an if statement. You could say, if os.GetEnv debug not equals empty string, then do something. But in fact, the value of that expression is just a Boolean value. It's true or false. It either is empty string or it isn't. And it's that value which we're assigning to hasDebug. So hasDebug is, by implication, Boolean, isn't it? So it's either true or false, which makes sense given the name. Do we hasDebug, or we don't has it? Either way. So what that's really saying is this variable is true if debug is set to something, and if it isn't, then we don't. That's reasonable, isn't it?
Clearer, right. That's true.
And presumably this debug thing is something like enabling extra verbose output, isn't it? You know, that's usually like, there's usually some level of logging where it's like, you know, I'm only going to tell you about important things or critical errors, and then it's like, something weird is going on and I don't understand what's going wrong, so I just need you to tell me everything. Far more information than I would ever normally ask for, but I want debug mode. And that sounds like that's what this is turning on. So
something was going on under the hood when, for example, given command runs, maybe.
Yeah. So I think you know, it's the fact that this is not obvious to us, that we need to talk about it a bit. It sort of says maybe this isn't a good thing to do, or, you know, or let's think about it. Could we write this another way so as to make it clearer what's really going on here? Any ideas?
I would use if statement.
Yeah, I think that's not unreasonable, is it? We could say, because we're used to seeing this kind of not equals expression in an if statement, that's just more familiar, isn't it? We could have said if os.getInfDebug is not empty string, then has debug is true, right? You could say else it's false, or you could start by setting it to false, and then you could override it to true if this thing is true. But this is sort of a more compact, if slightly less clear way of writing that. So, fine. What's next?